Hi everyone, welcome to section 4.4. We are now going to do one of my favorite activities in dealing with quadratics, and that is we are going to factor them. Hopefully this is a review for you, but even if not, I'm going to walk through step by step so that you will be hopefully okay. Before we start, I want to go back to a review multiplying binomials. I have these two expressions. Here's x plus 4 and x plus 2. And I'm told to multiply them. So I'm multiplying these two things, and the method that is used most often for multiplying these is called something called FOILing. So what you would do is all of x plus 2 has to be multiplied by both the x and the 4. And so how you do that is first you take the first times the first, x times x, which is x squared. Then you take the outer two, the first times, or the outer times the outer, x times 2 is positive 2x. Then you take the inner two are 4 and x, and that's plus 4x. And then you take the last two, which is 4 times 2, or positive 8. And then you combine like terms in the middle, and you get x squared plus 6x plus 8. So notice first we took this x plus 2, and we multiplied both of them by x. And then we took both of those and we multiplied them by 4, and we spelled out FOIL in the process of doing it. And we got this. Now I want you to notice something about this. It's pretty cool. This works whenever your x's are just one x, there's no coefficient in front of them, just single x's, and these binomials are simple like this. Then this middle term of 6 is these two numbers added together. Do you see how 4 plus 2 is 6? And then this third term of 8, the c, this is our a is 1, b is 6, c is 8, right? Our c of 8 are these two numbers multiplied. 4 times 2 is 8. So 4 plus 2 is 6, 4 times 2 is 8, and so that's why it's x plus 4 and x plus 2. That's what we're going to do. We're going to start with this, and we are going to figure out what these had to be in order to get this. So it's sort of like backwards FOILing. And we're going to look for those patterns. We're going to say what two numbers multiply to be 8 and add up to be 6. So the two numbers, the factors of 8, multiply to be 8 are 4 and 2, and when we add them we get 6, and so that's how we get our two binomials. Okay, let's practice that. All right, we have x squared plus 9x plus 20. There is just 1, and for x squared, there's nothing bigger than 1. So that means right away that this is going to factor like that, an x and a single x. Now we just need to think what two numbers will multiply to be 20 and add up to 9. If your multiplication skills are not that great, you can actually list all the factors if you need to. 1 times 20, 2 times 10, 4 times 5, list them all up and see which one of those combinations will add up to 9. And you see that it is 4 and 5. So this becomes, and it's positive, so it's positive 4x plus 4 and x plus 5, and you're done. It's as simple as that. Here's another example that's a little trickier. Notice when you multiply the two numbers, it's going to be negative. That means you're going to have one positive and one negative. So now that means their difference is going to be positive 14. So two numbers that multiply to be 72 and add up to 14. And 72 is a little trickier. It's, did I say 14? 14. It's 6 and 12 won't work. What are the other factors of 72? We may have to list them. 2 and 36, that won't work. And 3, okay, I already know, no wait. Does 3 goes into 72 how many times? 3, 23 and 24, that doesn't work. Okay, what about 4? 4 goes into 72, 36, 18. 4 and 18. That may be the process that you will have to go to. So sorry you had to sit there and watch, but I wanted you to see 4 and 18 will work. So let's do our x's, and we have 4 and we have 18. Now we have to figure out which one will be positive, which one will be negative. They add up to be positive, so this bigger one has to be our positive, this one has to be negative, and now we double check. All right? Negative 4 plus 18, positive 14. Negative 4 times 18, negative 72, and we've done it. So sometimes they can be trickier. If you see a situation like this, where this is not a plain positive one, it needs to be. So what you need to do in this first is factor out that negative so that this becomes a positive x squared. So what I'm going to do is I'm going to pull out the negative out to the side like this, or you can do the 1 or just leave it a negative, it doesn't matter. And since I pulled out the negative, that becomes positive. This becomes negative. That becomes positive. And now I can factor these. Now this one's another tricky combination, because when I multiply them, I'm going to get positive 12, which means I'm multiplying two numbers that the signs are the same. But when I add them, I get negative 13, which means I need to be adding a negative and a negative. So what two negatives multiply to be positive 12 and add up to be negative 13? And that's got to be negative 12 and negative 1. Negative 12 times negative 1 is positive 12. Negative 12 plus negative 1 is negative 13. And what I haven't written, but you cannot forget or you will get it wrong, is this negative is still out front. So just leave it right out front like that. Now you have factored it completely. Once you get the hang of factoring, it can be really fun and you can get pretty fast at it, but it just takes some practice. So let's do another one. X squared plus 14x plus 40. In fact, why don't you pause the video and try it on your own and then come back and see how you did. Okay, so you should have gotten two factors of 40 that add up to be 14 are 10 and 4, because 10 times 4 is 40 and 10 plus 4 is 14. So this is x plus 10 and x plus 4. By the way, the order does not matter. If you write x plus 4 times x plus 10, doesn't matter at all. So hopefully you did that one right. Here's another one. Go ahead and x squared minus 11x plus 30. Pause and see how quickly you can factor this yourself and then come back and check your answer. All right, hopefully you got this one. You got these negative signs and this positive. So you realize this would be x minus 5 times x minus 6, because when I add those two, I get negative 11, and when I multiply them, I get positive 30. One more with that added negative out front. Hopefully you remember what to do with that. Pause this one and try this one and then come back and we'll check your answer. Okay, so you should have factored out the negative first. Which would leave you with that. And now we need two numbers that multiply to be this and add up to be that. And it looks like it's going to be x minus 16 times x plus 2. And there we go. How did you guys do? Another aspect critical to factoring is looking for the greatest common factor. That's a fancy way of saying, what's the biggest thing that I can divide out of every single term in the expression? So we have this expression, 6n squared plus 9n, and I'm looking for something that's common to both terms that I can divide out. Except we're not going to use the word divide, we're going to say factor out. So I can factor these out. And if I look at just the number, or the numbers, this one's 6, this one's 9, I can factor out a 3 out of both of those, okay? So both of those can be divided evenly by 3. Also, when I look at the variables, they both have at least one n. So I can factor out a 3 and an n. So I'm going to put what I can factor out, I'm going to pull that out to the left, the 3 and the n. And now this is sort of like, instead of backwards FOILing, this is like backwards distributive property. So remember how when we distribute something into parentheses, everything gets multiplied by that? Now I'm pulling it back out, I'm dividing it out, so it's going to be back out in front. When I pull out the 3 from 6, I'm left with 2, because 3 times 2 is 6, or 6 divided by that 3 is 2, however you want to think about it. I pulled out 1 in, so I'm left with 1 in is left behind. Go to this term, it's positive, and then 9 in divided by 3 in, 9 by 3 is 3, and the ins were factored out, and so I'm finished. If you did it right, then what should happen is I should be able to multiply this expression by 3 in, use the distributive property, and it should get me back to this. If it does, then I factored correctly. Right, this, if you see GCF, that means the greatest common factor. What is common to all the terms, this factor that I can pull out and factor out. You want to look for that when you have factoring problems. Here's an example with a trinomial, and I've got some big numbers, so I want to do the same thing. Is there something I can factor out of all 3 terms first before I try to factor it out after that? I want to simplify it as much as possible. And if I look at all 3 of these terms, they don't all have an x, but they all can be divided by 4 evenly. The 4, and 56s can also be divided by 4. So let's factor out that 4. Let's pull it out to the left and then see what we're left with. In this term, it's just the x squared. In this term, it's a positive 5x, right? Because 20 divided by 4 is 5, and the x is still there. And then this one is negative, and 56 divided by 4 is 14, I think. And there we go. And now I can further factor this. What 2 numbers multiply to be negative 14 and add up to be 5? So we have x plus 7 and x minus 2. Those add up to be 5 and multiply to be negative 14. And now this is this trinomial fully factored. Here's the 4 I factored out first, and then my 2 binomials. Let's see how well you understand this. Here's another one that you can try on your own. Pause the video and see how you do with this. Come back and we'll check your answer just to see how good you are at factoring. Okay, you should have seen the only thing common to both of these was the 7. So when you factor out the 7, you're left with n squared minus 3, and you're done. Here's another one. You're going to look for that greatest common factor and then fully factor it. So after you pull out the greatest common factor, how can you factor it further? This one I'm not going to show you because this is your lesson check. So I want you to practice this, and I want you to bring your answer into me and see how well you did when you come back to class. So write that down, 9x squared plus 9x minus 18 for your lesson check for today's lesson. Okay, one last one. See how you guys do with this one. This one's a little tricky, so don't just stop the video. Pause and see how you do with this one, and then we'll walk through it together. All right, you should have seen right away that all 3 of these terms have a 4 in common, so you should have factored out that 4. And you were left with x squared plus 2x plus 3. All right, so now I'm going to look for, see if I can factor it further, 2 numbers that are multiplied to be positive 3 add up to be positive 2. And the only factors of 3 are 3 and 1, or 1 and 3. And I could have those added up to be 2 if I made my 1 negative and my 3 positive. But then if I multiplied them, this would have to be negative 3. So that doesn't work. And you're right. You cannot factor this any further. So this is completely done. All right, I hope you guys understand, see how that works. There are no 2 numbers that will add up to positive 2 and multiply to positive 3 at the same time. So this is completely factored. All right, so that is what we're doing for this section. Next time, we're going to look at how to factor if we have a number in front of the x squared that we can't just factor out, and how we deal with that. So we'll deal with that next time. For now, we'll just practice this, and I will see you guys then. So bye for now.